The pre-dawn gloom of June 17, 1944, on Saipan was shattered by the guttural cough of diesel engines. 44 Japanese tanks, a formidable armored column, rumbled toward the American lines, their crews confident, even triumphant, from years of battlefield success. They believed their Type 95 Hargau light tanks were invincible, perfectly adapted for the Pacific's unforgiving terrain, having crushed every foe they encountered. Yet, in mere moments, an unexpected American weapon, one not even designed for anti-tank combat, would expose the devastating truth about their revered machines, forever altering the course of the Pacific War and revealing a stark reality about industrial might versus fighting spirit. The revelation of this weapon's shocking effectiveness would reverberate through every future island campaign, fundamentally changing how Marines perceived and countered Japanese armor. The journey to this grim awakening began not with defeat, but with a deep-seated conviction born from years of unchecked victories. The Hargau was no mere accident of engineering, it represented the culmination of meticulous military planning initiated in 1933. Recognizing a glaring deficiency in their armored forces, the Imperial Japanese Army sought a successor to the Type 89 medium tank, whose paltry 15 miles per hour speed was deemed insufficient for the rapid, mechanized warfare they envisioned. Japanese strategists closely observed the development of faster, more agile armored divisions in other nations. They desired a tank capable of keeping pace with motorized infantry, which could travel at 40 miles per hour by truck. This new vehicle also needed to navigate the diverse landscapes of Manchuria and China and be produced in volumes sustainable by Japan's industrial base. In July 1933, the Army Technical Bureau issued precise specifications: a tank weighing approximately 7 tons, armed with a 37mm cannon, achieving speeds of 40 km per hour, and featuring armor sufficient to withstand rifle and machine gun fire. Crucially, it had to be straightforward to manufacture and maintain. Mitsubishi Heavy Industries secured the contract, with engineer Tomio Hara, already renowned for his work on the Type 89, leading the design effort. His most significant contribution was the bell crank suspension system, an elegantly simple yet highly effective design that would become a hallmark of Japanese tanks for the subsequent decade. By June 1934, Mitsubishi had completed the inaugural prototype. This initial model deeply impressed military observers during extensive field trials conducted both in Manchuria and at testing grounds within Japan. It demonstrated exceptional speed, reaching 45 km per hour on paved surfaces and maintaining a brisk 25 to 30 km per hour cross-country. Its maneuverability was remarkable, boasting a turning radius that seemed improbable for a tracked vehicle of its dimensions. Hara's distinctive bell crank suspension effectively absorbed shocks, enabling the tank to traverse rugged terrain that would have halted other vehicles. Furthermore, it proved mechanically robust, powered by a Mitsubishi 6-cylinder air-cooled diesel engine generating 120 horsepower at 1,800 revolutions per minute. The diesel engine was a particular source of pride for Japanese engineers, rendering the tank less susceptible to fires than its gasoline-powered counterparts. Diesel fuel was also more readily available throughout Japan's expanding empire, especially in regions like Manchuria and Southeast Asia, where gasoline supplies were often scarce. With an internal fuel capacity of 34 gallons, the engine could operate for 8 to 10 hours, granting the tank an operational range of approximately 130 miles on roads. While trials highlighted some issues, such as a tendency for the suspension to pitch violently on uneven ground, making accurate firing while moving nearly impossible and inducing crew fatigue, engineers swiftly responded. They added braces to connect the bogie pairs, creating what became known as the Manchuria suspension. This modification offered some improvement but never fully eliminated the rough ride that would define the Hargau throughout its service life. In 1935, at a pivotal meeting within the Army Technical Bureau, the Type 95 was formally presented as the prospective primary tank for mechanized infantry units. Infantry representatives voiced concerns, arguing that 12 mm of armor was inadequate for a tank intended to support infantry assaults against fortified positions. Cavalry representatives countered, asserting that the tank's enhanced speed and mobility more than compensated for its thinner armor, and that its firepower was perfectly sufficient for its designated role. Following extensive deliberation, the infantry reluctantly accepted the design. The Type 95 Hargao was officially adopted, its designation derived from the Japanese imperial calendar, marking the 2595th year since Japan's legendary founding, with only the final 2 digits used in the type number. Production commenced at Mitsubishi facilities in 1936. The Hargao was indeed a compact tank, measuring a mere 4.38 meters long, 2.06 meters wide, and 2.13 meters tall. In American terms, this translated to 14 feet 4 inches long, 6 feet 9 inches wide, and just under 7 feet tall, an average height man could easily peer over its turret. The basic tank weighed 7.4 tons, increasing to 8.1 tons when fully loaded with crew, fuel, and ammunition. Its armor was undeniably thin by any standard, 12 mm at its thickest points on the turret and upper hull, 9 mm on the roof and floor, and 6 mm in less critical areas. Japanese designers had calculated this to be adequate for stopping rifle and machine gun bullets at combat ranges, designing for the adversaries they anticipated facing, Chinese forces with limited anti-tank capabilities and light Soviet tanks. Inside, the tank was notoriously cramped. The crew consisted of 3 men. The driver was positioned in the front left of the hull, with restricted vision through a small viewport and periscope. A hull machine gunner sat to the driver's right, operating a Type 97 7.7 mm machine gun mounted in a ball joint. The commander occupied the turret alone, standing directly on the hull floor without the benefit of a turret basket. This commander likely endured one of the most demanding roles in the Imperial Japanese Army. He bore the responsibility of commanding the tank, directing the driver, and communicating with other tanks when a radio was available, a luxury only 1 in 4 tanks possessed, forcing others to rely on visual signals. He also had to operate the main gun, a Type 94 37 mm cannon capable of firing both high-explosive and armor-piercing rounds. Loading this gun was a physically taxing endeavor, made more arduous by the confined space and the necessity of standing. Furthermore, he was tasked with operating a second machine gun mounted in the rear of the turret, facing to the right rear at roughly the 5 o'clock position. American tankers who later examined captured Hargaos marveled that anyone could function effectively under such conditions. The Japanese commander lacked a seat in the turret, remaining standing throughout combat, his head and shoulders either exposed through the open hatch for improved visibility or confined to a tiny space with minimal sightlines if it was closed. The turret rotated via a hand crank, demanding significant physical exertion. There was barely sufficient room to move, let alone fight efficiently. Yet, in its intended role, against the opponents it was designed to combat, the Hargao performed exceptionally well. The tank first saw significant combat in China, beginning in 1937. Against Chinese forces, which possessed virtually no armor and limited anti-tank weaponry, the Hargao proved devastating. Its 37 mm gun could dismantle fortifications and suppress infantry, while its machine guns mowed down troops in the open. Its superior mobility allowed it to exploit breakthroughs and relentlessly pursue retreating forces. Japanese tank crews gained invaluable combat experience and confidence, learning their trade in an environment where their tanks were unequivocally superior to anything they encountered. This unbroken string of successes fostered a dangerous assumption, that the Hargao was a genuinely formidable tank, rather than a vehicle optimized for a specific, limited scenario. This assumption was severely tested at Khalkhin Gol in 1939, where Japanese forces clashed with the Soviet Union along the Mongolian border. Here, the Hargao met genuine opposition and failed. Soviet BT-5 and BT-7 tanks were equipped with 45 mm guns, offering superior armor penetration compared to the Japanese 37 mm. Soviet armor was also thicker, rendering frontal engagements particularly challenging for the Hargao. The battles were brutal. On July 2, 1939, the Japanese 3rd Tank Regiment, primarily equipped with Type 95 tanks, launched an assault on Soviet positions. The initial charge achieved some success through aggressive tactics and surprise, with Japanese tanks destroying 32 Soviet tanks and capturing 35 armored vehicles. However, Soviet counterattacks in the ensuing days brutally exposed the Hargao's vulnerabilities. Soviet guns could pierce the Hargau's armor at ranges where the Japanese guns struggled to inflict damage on Soviet tanks. By the conclusion of the Khalkhin Gol campaign, Japan had lost dozens of tanks. The lessons were starkly clear to any attentive observer: the Hargau was outmatched by modern Soviet armor. Its thin protection and relatively weak gun were utterly inadequate for tank-versus-tank combat against peer adversaries. Yet, these crucial lessons were not fully assimilated. Japanese military leadership instead focused on minor tactical improvements and crew training, rather than undertaking a fundamental redesign of their armored forces. The war in China continued, where the Hargau remained effective. When war erupted across the Pacific in December 1941, Japanese tank units achieved remarkable successes. In Malaya, Hargau tanks navigated terrain that British commanders had deemed impassable for armor. They moved through dense rubber plantations and jungle trails, providing crucial support for the rapid Japanese advance down the peninsula toward Singapore. British forces, having deployed minimal armor to Malaya, were caught entirely unprepared for this mobile threat. In the Philippines, Hargaus landed with the invasion force, effectively supporting Japanese infantry operations. On December 22, 1941, north of Demortis, Type 95 tanks engaged American M3 Stuart light tanks in what would be recorded as the first tank-versus-tank battle involving U.S. forces in the Pacific. Both tanks mounted 37mm guns. The M3 boasted superior armor, with 32mm on the turret sides compared to the Hargau's 12mm. However, in the close-quarters jungle fighting, the Japanese achieved some initial success, destroying one M3 in the opening engagement. These early victories further solidified Japanese confidence. From their perspective, the Hargau was performing precisely as designed: mobile, reliable, and effective in supporting infantry operations across diverse terrain. Tank crews trusted their machines, and commanders relied on their armor. So, when orders came to defend Saipan, the Japanese deployed their tanks without a flicker of doubt regarding their adequacy. Saipan, however, was a vastly different theater from the battles that preceded it. This island in the Mariana Chain held immense strategic importance, located a mere 1,250 miles from Tokyo. Should the Americans seize Saipan, their B-29 bombers would be within striking distance of the Japanese home islands. The empire's leaders understood this grave threat and heavily fortified Saipan with approximately 30,000 troops, nearly double American intelligence estimates. Among these defenders was the 9th Tank Regiment, commanded by Colonel Takashi Goto. The regiment fielded 44 tanks, a mix of Type 95 Hargaus and the slightly larger Type 97 Chiha medium tanks. While the Chiha was better armed with a 57mm gun, it shared the thin armor characteristic of Japanese tank design. By Pacific standards, this represented a significant armored force, certainly the largest the Americans had yet encountered. The American assault commenced on June 15, 1944. Vice Admiral Richmond Kelly Turner ordered the landing force ashore at 0542 hours. By 0700, landing craft were churning toward the beaches, and at 0840, the first wave hit the shore. The 2nd and 4th Marine Divisions landed on Saipan's western beaches under a torrent of fire from Japanese artillery and mortars positioned on the commanding heights overlooking the landing zones. The Marines fought their way inland against ferocious resistance. By nightfall of the 15th, 20,000 American combat troops were ashore, with equipment and supplies continuously pouring onto the beaches. Among this equipment were M4 Sherman medium tanks, disembarking from LST vessels and moving forward to provide infantry support. The Marines had established a beachhead, but it remained precarious. Japanese artillery could still reach the beaches, and counterattacks persisted throughout the night. On June 16, the Marines consolidated their positions and began their push inland. The 2nd Marine Division worked to close gaps in the line, while the 4th Marine Division systematically cleared areas around key terrain. Lieutenant General Holland Smith, commanding the assault force, committed his reserves, bringing elements of the 27th Infantry Division ashore to reinforce the beachhead. Lieutenant General Yoshitsugu Saito, commanding Japanese forces on Saipan, recognized the dire situation. If the Americans solidified their beachhead and brought their full combat power ashore, dislodging them would become an impossibility. He had to strike before they were fully prepared. Saito issued orders for a major counterattack, utilizing the island's most potent assets, the infantry of the 136th Regiment and the tanks of the 9th Tank Regiment. The attack order was concise: the infantry would assault American positions around Garapan, while the tank unit would advance southwest of Hill 164.6, moving after the infantry attack commenced. The tanks were to charge the transmitting station, throwing the enemy into disorder before the infantry penetrated the sector. It was an ambitious plan, demanding intricate coordination between infantry and armor in a night attack across challenging terrain. Colonel Goto gathered his tank crews. They conducted final maintenance checks on their vehicles. Crews loaded ammunition, 37mm rounds for the Hargaus, 57mm rounds for the Chihas. They topped off fuel tanks, verified track tension, and tested the radios on the few tanks that possessed them. The crews were confident, many had combat experience from China or earlier Pacific campaigns. They trusted their machines and their tactics. In the pre-dawn darkness of June 17, the Japanese tank column moved out. Diesel engines sputtered to life, their distinctive sound echoing across the landscape. Tracks clanked as the tanks formed up and began their approach toward the American lines. Inside each cramped vehicle, crews felt the familiar vibration and noise of their tanks in motion. Commanders stood in their turrets, straining to pierce the darkness, coordinating movement through visual signals. The Marines heard them coming. Sentries on the perimeter reported engine sounds from the north. Officers barked orders. Men grabbed weapons and scrambled to defensive positions. Anti-tank gun crews traversed their 37mm M3 guns toward the approaching sounds. Sherman tank crews, who had bedded down near their vehicles, clambered aboard and started their engines. Machine gun teams checked their weapons and ammunition. At 0330 hours, the Japanese attack began in earnest. 44 tanks, the largest armored formation yet committed by Japan in the Pacific, advanced toward the 2nd Marine Division's positions. Some tanks carried infantry clinging precariously to their hulls, a dangerous but sometimes effective tactic. The formation moved through the darkness, guided by the lead tanks and following the terrain toward their objectives. Marine riflemen saw them first as dark, hulking shapes emerging from the pre-dawn gloom. Then came the unmistakable sound of diesel engines at full throttle, tracks churning dirt and dust, the clank of bogie wheels, and the squeal of steel on steel. Japanese tankers could discern Marines in their positions, could see the defensive line ahead. Some commanders opened fire with their hull machine guns, sweeping the ground ahead, while others reserved fire, attempting to close the distance before engaging. Then, something entirely unexpected occurred, something that would fundamentally alter how Marines perceived Japanese armor for the remainder of the war. Marine machine gunners, positioned in foxholes and behind cover, opened fire with their Browning M2 heavy machine guns. These were not the standard infantry machine guns, the .30 caliber weapons that provided supporting fire. These were .50 caliber weapons, formidable heavy machine guns designed to engage aircraft and destroy light vehicles. The .50 caliber Browning M2 was a truly formidable weapon, conceived near the end of World War I and perfected over the ensuing decades. It fired a 12.7mm round at a muzzle velocity exceeding 2,900 feet per second. The standard ammunition load included ball rounds for general use and armor-piercing rounds specifically engineered to defeat light armor and fortifications. The armor-piercing variant could penetrate 23mm of face-hardened steel armor plate at 200 meters. Even at 500 meters, it could still penetrate 19mm. These were not theoretical figures, they were verified test results, confirmed through extensive firing trials at American ordnance proving grounds. The ammunition had been designed to engage lightly armored aircraft and vehicles, not to defeat tanks, but the unforgiving mathematics of armor penetration told a different story. The Type 95 Hargaus armor was a maximum of 12mm thick on the turret front and sides, and on the upper hull. The thickest armor on the entire vehicle was 12mm. Simple arithmetic revealed the profound problem. the .50 caliber armor-piercing round could penetrate nearly twice that thickness at close range. At the ranges where the battle was being fought, 200 meters or less as tanks closed with Marine positions, the .50 caliber had more than enough penetrating power. Marine machine gunners unleashed their fire. Tracer rounds arced across the battlefield in brilliant orange-red lines. The sound was distinctive, the heavy boom 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 of .50 caliber machine guns firing at a sustained rate. Gunners aimed at the advancing tanks, some not entirely convinced their weapons would be effective against armor. What transpired next shocked both sides. The .50 caliber armor-piercing rounds didn't merely dent the tanks, they didn't ricochet off at acute angles. They penetrated. Cleanly. Decisively. At close range, some rounds passed completely through the thin armor, entering one side of the tank and exiting the other. Even at longer ranges, the rounds punched through the armor with energy to spare. Inside the Japanese tanks, crews experienced something far worse than defeat, they experienced a horrifying revelation. The heavy machine gun fire wasn't just loud impacts on the exterior of the hull, it was penetration, rounds tearing through the armor. In the cramped interior of a Hargau, there was nowhere to hide. A round that pierced the hull could strike engine components or crew members. The face-hardened armor, designed to resist rifle fire, offered no meaningful protection against the heavy .50 caliber rounds. One Marine machine gunner, firing his weapon from a position near the airfield, recounted watching his tracer round strike a Hargau advancing directly toward him. The rounds hit the front hull, and he could see sparks erupting inside the tank through vision ports and hatches. The tank continued its advance for a moment, then slowed, then stopped. Engine smoke billowed from the rear deck. The crew attempted to bail out. Two men emerged, only to be immediately engaged by rifle fire from Marines in foxholes. Another gunner, positioned with his weapon mounted on a half-track, engaged a Hargau at approximately 150 meters. He fired a sustained burst into the tank's side armor. The tank turned toward him, exposing more of its flank. He continued firing, his loader feeding another belt of ammunition into the gun. He watched the commander in the turret slump forward, then fall. The bullet had torn through the thin turret armor, struck the man, and continued through the other side. The commander never knew what hit him. A third Marine, manning a .50 caliber in a fixed position on the defensive line, engaged multiple tanks as they advanced. He fired at one Hargau's engine compartment, aiming for the rear deck where the cooler vents were located. His rounds penetrated the thin 6mm armor covering the engine. The diesel engine, its cylinders ruptured by .50 caliber impacts, seized. The tank stopped moving, becoming a stationary target. The crew abandoned it, running back toward Japanese lines through a hail of small arms fire. Japanese tank crews who survived the initial assault couldn't comprehend what was happening. They had trained for years. They had fought in China, where enemy bullets bounced harmlessly off their armor. They had faced Soviet anti-tank rifles at Khalkhin Gol and lived. Their tanks were supposed to protect them, that was the fundamental premise of armored warfare. The tank's armor kept the crew alive while they engaged the enemy with superior firepower. But American machine guns were defeating their armor. Not anti-tank guns firing large-caliber projectiles, not artillery, not even the massive 75mm guns on the Sherman tanks they could see moving into position. Machine guns. Infantry support weapons. Weapons mounted on jeeps, on half-tracks, on virtually every vehicle in the American arsenal. The realization was devastating. If machine guns could penetrate their tanks, what chance did they have? A Japanese tank officer, later captured after his tank was disabled, told American interrogators that his first thought was that the Americans must have developed some new secret weapon, some advanced ammunition or special gun that looked like a standard machine gun but fired exotic projectiles. He simply could not accept the notion that a conventional heavy machine gun could defeat a tank. In his entire combat experience, from training in Manchuria to fighting in China, small arms had always been ineffective against armor. Bullets made noise on the outside, they didn't come through. But the Browning M2 was in an entirely different category from anything the Japanese had previously encountered. With its armor-piercing rounds, it possessed sufficient energy and penetrating power to defeat 12 mm armor at any range where a machine gunner could accurately engage a target. And the Marines had these weapons everywhere. They were standard equipment throughout the American military. As the Japanese tank attack faltered under this unexpected fire, Sherman tanks moved forward to engage. The contrast was stark. Where the Hargau weighed 7.4 tons, the M4A2 Sherman, the variant used by Marines at Saipan, weighed 31.8 tons. Where the Hargau had 12 mm of armor, the Sherman had 51 mm on the frontal hull, angled at 56 degrees to provide effective protection equivalent to approximately 75 mm against anti-tank fire. The Sherman mounted a 75 mm gun as its main armament. This gun could penetrate the Hargau's armor from over a mile away. When Shermans opened fire on the Japanese tanks, the outcome was predetermined. 75 mm armor-piercing rounds struck Hargaus and Chihas with devastating effect. Tanks were blown apart. Turrets were knocked off hulls. Ammunition detonated in crew compartments. Japanese tanks that returned fire found their 37 mm and 57 mm rounds utterly ineffective against the Sherman's frontal armor. The shells bounced off or created small dents without penetrating. One Japanese tank commander, whose Hargau was disabled by .50 caliber fire but whose turret could still traverse, attempted to engage a Sherman at close range. He ordered his gunner to fire. The 37 mm gun fired its armor-piercing round. The projectile struck the Sherman's turret face. There was a flash of impact. The Sherman didn't even slow down. It continued to rotate its turret with mechanical precision, aimed, and fired a single 75 mm round. The Hargau exploded. The battle evolved into what one Marine officer later described as a madhouse of noise, tracers, and flashing lights. Disabled tanks burned, illuminating other tanks still trying to advance. Infantry who had been riding on the tanks scattered, seeking cover in shell holes and drainage ditches. Some Japanese infantry made it to the Marine lines, fighting desperate close-range battles in and around American positions. Marine infantry, hunkered in their foxholes, found themselves with Japanese tanks passing directly over them. One Marine later reported that a Hargau, leaking oil heavily, soaked him as it passed over his position. He remained still until it moved on, then emerged and threw a thermite grenade into the engine compartment as the tank moved past. The tank began burning from the inside. Another Marine, lying low in his foxhole as a tank rolled over him, jumped out after it passed and jammed a coconut log into the bogie wheels. The tank spun in place, tracks throwing dirt, unable to move forward. When the confused tank commander opened his turret hatch to see what was wrong, the Marine jumped onto the tank and dropped a thermite grenade into the open turret. The tank exploded from internal fires, igniting all ammunition. By the morning of June 17, the Japanese counterattack was over. 31 destroyed Japanese tanks littered the battlefield, counted by Marines walking through the area after the fighting stopped. Some sources suggest as many as 35 tanks were destroyed, including those knocked out by artillery fire beyond the immediate battle area. Perhaps 1,000 Japanese soldiers were dead, including many of the tank crews and the infantry who had advanced with them. For the Marines, the victory was significant but grim. They had stopped a major armored assault, but the cost had been substantial. The 2nd Marine Division's commander later acknowledged that if the Japanese attack had succeeded, it would have been fatal to the division's fighting efficiency. The battle had been close, decided as much by American firepower and Japanese tactical errors as by overwhelming superiority. But for Marines walking among the destroyed tanks afterward, examining the vehicles up close, a different truth emerged. The Japanese tanks were not the formidable war machines they had expected. A Marine officer called his men over to look at a destroyed Hargau. He pointed to the holes in the armor. They were clean, round penetrations where .50 caliber bullets had punched through. The exit holes on the far side were slightly larger, rough-edged where the bullets had torn through after crossing the interior. You could put your fist through some of the holes. Inside the destroyed tank, the scene was worse. The cramped interior showed signs of multiple penetrations. The commander's position in the turret had no protective features, no armor that would stop heavy machine gun fire. The manual traverse for the turret consisted of a simple hand crank. The gun controls were rudimentary. There was almost no space to move. The hull machine gunner's position was a small cubby with minimal visibility. The driver had a crude periscope and a small vision port. Everything was cramped, crude by American standards, and utterly vulnerable to .50 caliber fire. Marines who had fought at Guadalcanal 2 years earlier remembered seeing Hargaus there. At the time, with Marines equipped primarily with light weapons and no armor support of their own, the Japanese tank had seemed threatening. But now, with proper equipment, with heavy weapons and their own armor, the Hargau looked exactly like what it was, a light tank from the mid-1930s, adequate for its original design parameters, but utterly inadequate for modern industrial warfare against a peer adversary. The psychological impact on surviving Japanese tank crews was profound. Those who were captured, whose disabled tanks left them with no choice but surrender, had to grapple with uncomfortable truths. Their tanks were not just outmatched, they were obsolete. The equipment they had trusted with their lives offered no protection against weapons the Americans used as standard infantry support. Intelligence officers interrogating prisoners noted a consistent pattern in their responses. They expressed shock at American firepower. They talked about the quantity and quality of American equipment. They mentioned the casual abundance of ammunition and supplies they had witnessed. Many expressed feelings of betrayal that their own leaders had sent them into battle with inadequate equipment while telling them they had technological parity or even superiority. One veteran tank commander, who had fought in China since 1937, told interrogators that he had believed Japan would win the war through superior fighting spirit and devotion to the emperor. After Saipan, after seeing his tank penetrated by machine gun fire, after watching American Sherman shrug off Japanese anti-tank fire, he knew that spirit could not overcome material disadvantages. Training and courage meant nothing when your equipment was fundamentally inadequate. These reports were compiled, analyzed, and disseminated to commanders throughout the Pacific. The lessons learned at Saipan would inform Marine tankers for the rest of the war. Japanese tanks were not a serious threat. Standard infantry heavy weapons, particularly the .50 caliber machine gun, were effective against them. Combined with bazookas, 37mm anti-tank guns, and Sherman tanks, Marines possessed overwhelming firepower against Japanese armor. Word spread through the Marine ranks quickly: you didn't need specialized anti-tank weapons to engage a Japanese tank, your .50 caliber machine gun would do the job. This knowledge fundamentally changed how Marines approached subsequent island battles. The fear that came with facing armor, the concern about tanks breaking through infantry lines, evaporated. Japanese armor became just another target, and not a particularly dangerous one. The Battle of Saipan continued for weeks after the failed tank attack. Marines and Army troops fought their way across the island against fierce Japanese resistance. The terrain was brutal, ranging from flat sugarcane fields to swamps, to volcanic cliffs and Mount Tapasho, which rose 1,554 feet above sea level. Caves, ravines, and gullies consumed men and ammunition. The island was declared secure on July 9, 1944. The victory at Saipan had strategic consequences that reached far beyond the island. With the Marianas in American hands, B-29 bombers could reach Tokyo. The psychological impact on Japanese leadership was severe. Emperor Hirohito recognized that American control of Saipan meant Tokyo would be bombed. Prime Minister Hideki Tojo resigned on July 18. For the first time, Japanese media admitted the war was going poorly. The loss shook Japan's confidence in ultimate victory. For Japanese tank crews across the Pacific, Saipan was a turning point. Word of the battle spread through military channels. Tank units on other islands heard what had happened. They knew their equipment was inadequate. They knew American weapons could penetrate their armor, but there was nothing they could do about it. The tanks they had were the only tanks Japan could provide. Japan's industrial capacity simply could not produce modern tanks in meaningful numbers. The nation's factories were strained by years of war. Resources were limited, with American submarines cutting off access to raw materials from Southeast Asia. Strategic priorities focused on aircraft production for kamikaze attacks and on coastal defense artillery for the anticipated invasion of the home islands. Tanks were a low priority. Japanese engineers had designed better tanks, the Type 3 Chinu with a 75mm gun, the Type 4 Chitu with even heavier armament. But these existed primarily as prototypes and in small production runs. Only 166 Chinus were built during the entire war, and only 2 Chitos. None saw combat. They were saved for the defense of Japan itself, never sent to the island battlefields where they might have made a difference. Meanwhile, American production capacity was almost incomprehensible by Japanese standards. The Detroit Tank Arsenal, built by Chrysler Corporation, was a purpose-built facility dedicated solely to tank production. In December 1942 alone, the arsenal's 5,000 workers produced 907 Sherman tanks. That was more tanks in a single month than Japan produced in an entire year. The arsenal was not alone in this remarkable production achievement. Fisher Tank Arsenal, built in Grand Blanc, Michigan, was another government-funded facility operated by General Motors' Fisher Body Division. Fisher produced over 11,000 Shermans in multiple variants, making it one of the highest volume producers. Like the Detroit Arsenal, Fisher could produce hundreds of tanks per month when operating at peak capacity. American Locomotive Company in Schenectady, New York, converted from locomotive production to build 2,300 Sherman tanks. Baldwin Locomotive Works in Philadelphia produced over 1,200 tanks while maintaining locomotive production for the war effort. Lima Locomotive Works in Ohio built the first production M4A1 Sherman, a tank named Michael that was shipped to England and still resides at the Bovington Tank Museum. Lima produced 1,655 tanks before returning to full-time locomotive production. Pacific Car and Foundry in Washington State, Pressed Steel Car Company in Pennsylvania, Pullman Standard Manufacturing in Illinois, and Federal Machine and Welder in Ohio all contributed to Sherman production. These 8 primary manufacturers, plus countless subcontractors producing components like tracks, engines, radios, optics, and weapons, represented an industrial mobilization unprecedented in human history. The Detroit Arsenal itself was a marvel of modern production engineering. Built on 167 acres in Warren, Michigan, the facility covered over 1.5 million square feet of production space. Assembly lines snaked through the building floor for miles. Massive overhead cranes could lift complete tank hulls and move them between workstations. The factory operated 3 shifts, 24 hours per day, 7 days a week. Workers included men who had been automotive workers before the war, bringing their manufacturing expertise to tank production. But they also included thousands of women, many of whom had never worked in heavy industry before. These women, often called Rosie the Riveters, welded armor plate, assembled turrets, installed engines, and performed every job in the plant except the heaviest lifting tasks. They proved that the nation's industrial capacity could be multiplied by tapping a workforce that had been largely excluded from heavy manufacturing in peacetime. By the time production ended in June 1945, American factories had built 49,234 Sherman tanks. Japan produced approximately 2,300 Hargaus over the entire course of the war, from 1936 to 1943 when production ceased. The ratio was more than 20-1. But even that figure understates the disparity, because American tanks were far more capable individually than their Japanese counterparts. Sherman tanks weighed 30 to 35 tons depending on variant. They had armor ranging from 51 mm on the hull front to 76 mm on the turret mantlet. They carried 5-man crews with dedicated positions for each role. They had gyro-stabilized guns that allowed firing while moving. They had radio communication equipment in every tank, enabling coordinated operations. They were reliable, with tracks that lasted 2,500 miles compared to 500 miles for German tanks and perhaps 1,000 miles for Japanese tanks. The Sherman was not the best tank of World War II, it was outgunned by German Tigers and Panthers. But it was good enough, and it was available in overwhelming numbers. In the Pacific Theater, where it faced Japanese tanks designed in the mid-1930s, the Sherman was more than adequate, it was overwhelmingly superior. For Japanese tank crews on subsequent islands, the pattern established at Saipan repeated itself. On Tinian in July 1944, 7 Type 95s were destroyed in counterattacks against Marine positions. On Polilliu in September 1944, Japanese tanks were dug into caves and used as stationary pillboxes, recognizing they had no chance in mobile warfare. On Iwo Jima in February 1945, Colonel Takichi Nishi's 26th Tank Regiment buried their tanks in volcanic ash up to the turret, using them as armored bunkers because the tanks provided more protection when stationary than when moving. Even used as static defensive positions, the tanks remained vulnerable. .50 caliber machine guns could still penetrate the turret armor. Flamethrower tanks could direct napalm into open hatches and vision ports, cooking crews alive inside their steel coffins. Bazookas could penetrate the thin armor from any angle. The Hargao, once a symbol of Japanese armored might, had become a death trap for its crews. On Okinawa, the last major battle of the Pacific War, the Japanese committed the 27th Tank Regiment to the defense. The regiment had 13 Type 95 Hargaus and 14 Type 97 Chiha medium tanks, a total of 27 tanks. The Americans landed with over 800 tanks. The numerical disparity was 30-1. The qualitative disparity was even greater. On May 4 and 5, 1945, the Japanese launched a major counteroffensive designed to drive the Americans off the island. Tank units were committed to support the Japanese infantry assault. The attack failed catastrophically. Most of the Japanese tanks were destroyed within hours, knocked out by a combination of Sherman tanks, bazookas, 37mm anti-tank guns, artillery, and .50 caliber machine guns. The survivors withdrew, having accomplished nothing except adding more destroyed hulls to the battlefield. In August 1945, when the Soviet Union declared war on Japan and invaded Manchuria, Japanese tank units in northern China faced yet another technologically superior opponent. Soviet T-34 medium tanks, with their sloped armor and powerful 76mm guns, vastly outclassed the Japanese tanks opposing them. In the Battle of Shumshu Island, part of the Kuril chain, Japanese tanks attempted to defend against Soviet amphibious landings. The Japanese had a mixed force of approximately 77 tanks on Shumshu, including Type 97s and some newer Type 1 medium tanks, with only 25 Type 95s. The Soviets used 45mm anti-tank guns, anti-tank rifles, and anti-tank grenades to devastating effect. The Japanese lost 21 tanks in approximately 2 hours of fighting. Soviet forces, experienced in armored warfare from years of fighting on the Eastern Front in Europe, made short work of the Japanese defenders. The experience of Japanese tank crews during World War II, particularly in the final years, was one of gradual, crushing realization that what they had believed about their equipment, about their chances, about their ability to compete with Allied armor, was fundamentally wrong. The moment of truth for many came not in some epic tank duel between armored champions, but in the terrible simplicity of watching machine gun bullets punch through armor that was supposed to protect them. For Marines who fought at Saipan and subsequent islands, the lessons were different but equally profound. They learned that Japanese tanks were not a serious threat. They learned that proper equipment and overwhelming firepower made all the difference. They learned that their .50 caliber machine guns, which they had trained with and maintained throughout their service, were actually effective anti-tank weapons in the Pacific Theater when engaging thinly armored Japanese vehicles. There was no glory in these lopsided battles. Marines didn't feel heroic shooting at tanks with machine guns and watching them burn. They felt a mixture of relief, pity, and grim satisfaction. Relief that they didn't have to face serious armor opposition, the kind their counterparts in Europe dealt with daily against German tanks. Pity for the men in those Japanese tanks who had been sent to die in equipment that offered them no real protection. Satisfaction that their weapons worked, that American industry had given them the tools they needed to do their job. After the war ended, some surviving Hargau tanks were shipped to the United States for detailed examination at the Aberdeen Proving Ground in Maryland. American engineers and armor specialists studied them carefully over a period of months. They measured armor thickness at multiple points on the hull and turret, documenting the variations: front hull 12 mm, side hull 12 mm, rear hull 10 to 12 mm, turret front 12 mm, turret sides 12 mm, roof plates 9 mm, belly armor 6 mm. They tested the quality of the steel using metallurgical analysis. The armor was face-hardened, a process that made the outer surface harder than the interior core. This technique was effective against small arms fire, causing bullets to shatter rather than penetrate. But it was ineffective against larger projectiles with sufficient energy to break through the hardened outer layer and penetrate the softer interior. They evaluated the internal layout, taking detailed measurements and photographs. The fighting compartment provided barely 50 cubic feet of space for the commander. He had to stand, constantly, with no seat and no resting position. The turret ring diameter was just 1,200 mm, leaving minimal space for a man to work while also operating weapons, loading ammunition, and commanding the tank. Other crew positions were cramped to the point of claustrophobia. The driver had a space approximately 2 feet wide and 3 feet deep. His controls were simple, consisting of steering levers, a throttle, and a gear shift. His vision came from a small armored periscope and a direct vision port that could be opened in non-combat situations. The hull machine gunner beside him had even less space, confined to a small cubby with his weapon and limited ammunition storage. American tankers who examined the Hargaus could not imagine fighting in such conditions. Sherman crews, by comparison, had a fighting compartment that provided over 150 cubic feet of working space. Each crew member had a defined position with proper seating. The commander had a cupola with all-around vision blocks. The gunner had a telescopic sight and power traverse for the turret. The loader had space to move and access to properly organized ammunition racks. Driver and assistant driver, called the bow gunner in American nomenclature, had adequate space and vision equipment. Their reports confirmed what had been learned in combat and what mathematics had predicted. The Hargau was a light tank suitable for operations against poorly equipped opponents. It could function effectively in colonial warfare, in police actions, in suppressing resistance where the enemy had no serious anti-tank capability. It was not suitable for modern industrial warfare against a peer adversary with proper weapons. Any firearm more powerful than a rifle could defeat its armor. The .50 caliber armor-piercing rounds didn't just penetrate, they overpowered the armor completely, punching through with energy to spare. The internal arrangement was cramped to the point of being actively dangerous even without enemy fire. The commander's workload, handling all turret functions alone, was unrealistic. The lack of radio equipment in 3 of every 4 tanks made coordinated operations nearly impossible. The hand-cranked turret traverse was exhausting and slow. The vision equipment was crude, leaving the crew largely blind to their surroundings, forcing commanders to expose themselves by opening hatches to see what was happening around them. Every aspect of the design reflected the constraints Japan faced: limited industrial capacity, resource scarcity, and a design philosophy rooted in experiences against inferior opponents. The comparison with American tanks revealed the full extent of the design philosophy differences. Where the Hargau was cramped, the Sherman was relatively spacious, with enough room for crew members to move, switch positions if necessary, and work effectively even during extended combat operations. Where the Hargau had thin armor vulnerable to machine gun fire at close range, the Sherman resisted dedicated anti-tank guns at combat ranges. Its 51 mm frontal armor, angled at 56 degrees, provided effective protection equivalent to approximately 75 mm against anti-tank projectiles. Where the Hargau had a single-person turret crew performing multiple simultaneous tasks, the Sherman had 3 men in the turret. The commander could focus on commanding, using his cupola with 6 vision blocks to maintain situational awareness and direct the crew. The gunner focused exclusively on aiming and firing the main gun, using a telescopic sight with magnification and a power traverse system that could rotate the turret quickly and smoothly. The loader focused on maintaining a high rate of fire, pulling rounds from organized racks and loading them efficiently. The Sherman 75mm gun had a muzzle velocity of approximately 2,400 feet per second with standard ammunition, giving it effective armor penetration against most targets it would face in the Pacific. The gun was stabilized in the vertical axis, allowing reasonably accurate fire even while the tank was moving, a capability the Hargau completely lacked. The Sherman carried 97 rounds of 75mm ammunition in protected racks, compared to the Hargau's 130 rounds of 37mm ammunition stored loosely throughout the fighting compartment. Communication capabilities differed dramatically. Every Sherman had a radio, usually an SCR-528 or SCR-538 set, allowing tank-to-tank communication and coordination with infantry and artillery. The Hargau had radios in only one tank out of 4, leaving the other 3 to follow visual signals, a system that broke down quickly in combat when smoke, terrain, and enemy action made visual contact impossible. Vision equipment on the Sherman included periscopes with replaceable prisms, direct vision with armored covers, and a commander's cupola that provided all-around observation. The Hargau had crude periscopes and small vision ports that provided minimal situational awareness, forcing commanders to expose themselves by opening hatches to see what was happening around them. Every aspect of design, from ammunition storage to crew comfort, to fire control equipment, to communication systems, was better on the American tank. But the most telling difference was not in the individual tanks. It was in the numbers and in the industrial systems that produced them. The United States had built an economy that could wage industrial warfare on a global scale. Factories that had produced automobiles now produced tanks at rates that would have seemed impossible in peacetime. The Detroit arsenal alone, in its peak production month, produced more tanks than Japan produced in a typical year. Women who had never worked in heavy industry welded tank hulls and assembled turrets. Engineers constantly improved designs, incorporating lessons learned in combat. The supply chain delivered raw materials to factories and finished tanks to ports with clockwork efficiency. Merchant ships carried Shermans across both oceans to battlefields in Europe and Asia. Maintenance units in the field kept tanks operational, cannibalizing damaged vehicles for spare parts and returning repaired tanks to combat within days. Japan had never built this kind of industrial system. Its economy was strained by years of war in China before the Pacific War even began. Its factories lacked the automation and mass production efficiency of American plants. Its access to raw materials, particularly after American submarines began sinking merchant shipping, was increasingly strained. The nation that had challenged the world's greatest industrial power was discovering the true cost of that challenge with each new battle. For the Japanese tank crews on Saipan that early morning in June 1944, and for every Japanese tanker who fought in the Pacific afterward, the lesson was brutal and clear. They were obsolete, their equipment was obsolete, their tactics, developed for a different kind of warfare against different opponents, were obsolete, and there was nothing they could do about it except continue fighting with what they had, knowing that survival was unlikely and victory impossible. The Marines on the other side learned different but equally important lessons. They learned that industrial might matters in modern warfare, that having better equipment in larger quantities makes an enormous difference. That courage and training and fighting spirit, while important, cannot overcome fundamental material disadvantages. They learned that the factories back home in Detroit, Pittsburgh, Cleveland, and dozens of other industrial cities were as important to victory as anything that happened on the battlefield. They also learned something specific and immediately practical: when you encounter a Japanese Hargau tank, you don't need to call for anti-tank support or airstrikes or artillery, though all of those are available if needed. You can engage it yourself with your .50 caliber machine gun. At close range, under 200 yards, the armor-piercing rounds will penetrate. Aim for the engine compartment, the sides, or the turret. The bullets will go through, disabling the tank and likely killing or wounding the crew. The weapon that was designed to shoot down aircraft and destroy light vehicles works just fine against Japanese armor. It was a small tactical lesson in a massive war. But for the men involved, for the Japanese tankers who died in their inadequate machines, and for the Marines who destroyed them with heavy weapons, it was a moment of absolute clarity. This was not a fair fight. This was not an even match. This was modern industrial warfare, where one side had overwhelming material superiority. The outcome was never in doubt. The Hargao tanks on Saipan and on every other Pacific battlefield where they fought represented more than just obsolete armor. They represented the gap between what Japan needed and what Japan could produce. They represented the impossible situation Japanese soldiers faced, ordered to fight a superpower with equipment that was never designed for that kind of war. They represented the consequences of strategic decisions made earlier, to prioritize naval and air power over ground forces, to assume that fighting spirit could compensate for material inferiority, to believe that early victories indicated long-term viability. When those first .50 caliber rounds punched through Hargao armor on Saipan, they proved something that would echo through the rest of the Pacific War and into the post-war analysis of why Japan lost. They proved that in industrial warfare between modern nations, production capacity matters, design philosophy matters, resource allocation matters. No amount of courage, training, or tactical skill can overcome a 10-to-1 numerical disadvantage, combined with generational gaps in equipment quality. The Japanese tank crews who climbed into their Hargaos that morning in June 1944 believed they were going into battle with reliable, capable machines. By the time the sun set on June 17, those who survived knew the truth. They had been sent to fight with armor so thin that machine gun bullets went straight through. They had been given equipment that was adequate for the war Japan planned to fight in the 1930s, but utterly inadequate for the war Japan found itself fighting in the 1940s. And there was nothing they could do about it except continue serving, continue fighting, and continue dying in machines that could not protect them.